dear student, how are you all? Welcome back again to our online lessons. I am Miss Esraa and I am going to be your math teacher for our online lesson today. Today we will take lesson 53, which is talking about addition and multiplication facts. Let's start our lesson. In this lesson, we will take some addition and multiplication facts that will help you to solve addition and multiplication problems. Let's take the first fact here. The first fact in our lesson is talking about adding to 0. When you add 0 to a number, the number stays the same. As you see in this example, when we add 0 to number 5, we get number 5 itself. We get the same number. We have another example. 8 plus 0 equals 8. Because when you add 0 to any number, this number stays the same. So 8 plus 0 equals 8. We have another example. 26 plus 0 equal 26. So when you add 0 to any number, this number stays the same. Here we have 6 plus 635. The result will be 635. 0 plus 3,589. The result is 3,589. So any number adding with 0 doesn't change the number, as you see in the last examples. The second fact in our lesson is multiplying by 0. When you multiply 0 by any number, the product always 0. Here we have 0 by 5 equals 0. Let's take more examples. 8 by 0 equals 0. 26 by 0 equals 0. 0 by 635 equals 0. 0 by 3,589 equals 0. So the product of any number and 0 is 0. Zero by 62 is 0. As you can see right here. Here 0 is fighting 62. And then at the end we find that 0 is the winner. So 0 is the king. So when we multiply any number by a 0, we always get 0. So in multiplying by 0, we find that 0 is the king. So the result always is 0. The third fact in our lesson is adding to 1. 1 plus 5 equals 6. 1 plus 24 equals 25. Do you notice anything here? Yes. We notice that if you add 1 to the given number, we get the next number of that number, or we get the number that comes after that number. As we can see here, when we add 1 to 5, we get 6. 6 here is the number that comes after 5. In the next example, when we add 1 to 24, we get 25. 25 here is the number that comes after 24. Let's take more examples. 1 plus 999. We get the number that comes after 999. which is 1000. 64 plus 1 equals 65. So here, when we add 1 to 64, we get the number that comes after 64, which is 65. 450 plus 1 equals 451. Okay, let's take the fourth fact in our lesson, which is talking about multiplying by 1. Here, I want to get the product of 1 by 2. We get number 2. 1 by 25, we get 25. So we notice here that any number multiplied by 1 gives the same result as the number itself. So when we multiply 2 by 1, we get 2 itself. When we multiply 25 by 1, we get 25 itself. Let's take more examples. When we multiply 67 by 1, we get 67. When we multiply 1 by 7,345, we get 7,345 itself. When we multiply 1 by 934, we get the number itself, which is 934. So here, number 1, play a role like a mirror. So in this example, I want to get the product of 6 by 1. Here, number 1, play a role of a mirror. So when 6 is 1, he looks back and sees him itself. So the answer is 6 itself. So number 1 here, like a mirror. So when we multiply 6 by 1, we get the result 6, as 6 can see itself in the mirror, which is number 1. So the result is always 6. 6 by 1, 6. 7 by 1, 7. 100 by 1, 100. So number 1 plays the role of a mirror. Okay, let's take the fifth fact in our lesson, which is talking about adding in any order. Here we have two examples. 6 plus 2 equals 8. And if we switch these two numbers and write 2 plus 6, we also get 8. So changing the order of the numbers we are adding doesn't change the sum. Okay, if you write 6 at first and then you add 2 to 6, you get the same result as you write 2 at first and then add 6 to number 2, we get the same result. Okay, that is called commutative property of addition, that states the answer or the sum remains the same. The sum remains the same. The sum, which is here 8, remains the same when adding numbers, even if the order of numbers are changing. Let's take the fact number 6, which is talking about multiplying in any order. Here, when we multiply 2 by 5, we get 10. If we switch these two factors and write 5 at first and then write 2 at second, we get the same product, which is 10. So here 2 by 5 equals 5 by 2 equals 10. So here we notice that changing the order of multiplication doesn't change the product. That is called commutative property of multiplication. States that the product, which is 10 here, remains the same when multiplying numbers, even if the order of numbers are changed, even if we switch between these two factors. If we write 2 at first and then we multiply 5 by 2, is the same product as we write 5 at first and then we multiply 2 by 5. The product here remains the same. Here is an example of how the sum doesn't change even if the order of the add-ins is changed. Here we have examples. I want here to get the sum of 2 plus 4. 2 plus 4 equals 6. If we switch between these two add-ins, which are 2 and 4, and write 4 at first, and then write 2 and the second, the sum of 4 plus 2 is also 6. So here 2 plus 4 equals 6 is the same as we write 4 plus 2 is equal 6 also. In multiplying in any order fact, here is an example of how the product doesn't change even if the order of the factors is changed. Here we have here two balloons and I want to get the product of 2 by 3 balloons. The product of 2 by 3 equals 6. If we switch between these two factors and write 3 at first and then we multiply 2 by 3, the product doesn't change. So when we write 2 by 3 equals 3 by 2 equals 6. So the product here doesn't change even if the order of the factors change. Fact number 7, doubling numbers. To get a double of a number, we add the same number to itself. Adding same number twice is doubling it, which we mean by this is to multiplying the number by 2. In this example, we have here 4 plus 4. 4 plus 4 equals 8. Here in this example, we double number 4. We double number 4 and write it twice. Okay, 4 plus 4 equals 8. Doubling a number means that we multiply this number by 2. So here we double number 4 and we can write it as, instead of we write 4 plus 4, we can write it as 2 by 4, which is equal 8. We can here draw two groups of 4 to represent the multiplication. The first group here has 4 and the second group here also has 4. So here we have 4 plus 4, which is equal 8, or we can represent the addition sentence with multiplication. We count how many groups here? We have here 2 groups. Each group has 4. So we can write 4 plus 4 as 2 by 4 because we have here two groups. Each group has 4 elements. Okay, so 4 plus 4, we can write it as 2 by 4 because here number 4 is double. We double number 4 here, and doubling means that we multiply this number by 2. Okay, the eighth fact here, multiplying big numbers. The distributive property helps in making difficult problems simpler. You can use the distributive property of multiplication to rewrite expression by distributing or breaking down a factor as a sum of two numbers. Break apart big numbers into two smaller numbers help us to find the product easier. Let's see examples. Here I want to get the product of 5 by 9. Okay, here we can break apart a big number, which is here number 9 is a big number. 9, we can write it as the sum of two numbers, 4 and 5. And here we can write the multiplication sentence here as 5 by 4 plus 5 by 5. So here we break number 9, which is the big number, into two numbers, 4 and 5, and then we multiply 5 by 4 and multiply 5 by 5 to make it easier to solve. So here we know the product of 5 by 4, which is 20, and also we know the product of 5 by 5, which is equal 25. So 20 plus 25 equals 45. So here in this problem, if you forget the product of 5 by 9, you can break apart number 9 into two smaller numbers, which is here 4 and 5, to make it easy to solve. Okay, here we have another example. Here I want to get the product of 4 by 7. Okay, 7 here is the big number. We can break apart 7 into two smaller numbers. Here in this example, we break apart number 7 into 5 by plus 2. 5 plus 2 equals 7. So here, to make this problem easier to solve, we break the big number, which is 7, into two smaller numbers. Okay, and then we will multiply number 4 by 5 at first time, then we will multiply number 4 by 2. This is easier to solve this example. Here I know the product of 4 by 5, which is equal to 20. And I know the product of 4 by 2, which is equal to 8. So 20 plus 8 equals 28. Now it's time to solve this exercise with me. Complete using addition or multiplication to find the result. The first example here we have 85 by 0. Do you remember? When you multiply 0 by any number, the product always equal 0. So 85 by 0 equals 0. The second one, 135 by 1. Any number multiplied by number 1 gives the number itself. So the product here is 135. We write the number itself when we multiply it by 1. 75 plus 0. When you add 0 to any number, the number stays the same. So 75 here stays the same. So the result is 75. 36 plus 1. When you add number 1 to any number, you will get the number that comes after that number. What is the number that comes after 36? Yes, 37. So the result here is 37. 5 by 7. Here we can break apart number 7 into two parts because 7 here is a big number. We can break apart 7 into two smaller numbers, 4 plus 3, and then we will multiply 5 by 4, and then we will multiply 5 by 3 and get the sum of these two products. 5 by 4 equals 20, and 5 by 3 equals 15. Then we add these two products to get the product of 5 by 7. So 5 by 7 here equal 20 plus 15, which is equal 35. 8 plus 8. Do you notice anything here? Yes, we doubled the number 8. When we double any number, that means that we multiply this number by 2. So here we will multiply 8 by 2 to get 16. 0 by 0. When you multiply 0 by any number, even if 0 itself, the product always 0. So the result here is 0. 65 by 10 equals 650. From the last lessons, we multiply the two single-digit factors. 65 by 1 is 65, and then we count how many zeros are there here. We have here 1 0. So we add 0 to 65 to get the product of 65 by 10, which is equal 650. 1 by 1. Any number multiplied by 1, even if 1 itself, it gives the number itself. So 1 by 1 here equals 1. 0 by 14. When you multiply 0 by any number, the product always 0. Write the missing number. 4 by 6 equals 6 by what? Here it is the commutative property. When you switch between these two factors, the product still the same. When you write 4 at first and then you write 6 at second, it is the same product as you write 6 at first and then 4 at second. So the missing number here is 4 because 4 by 6 equals 6 by 4. So the result here is 4. Question number 2. 9 by what equals 9? What number we can multiply by 9 to get the same number 9? Do you remember number 1? When play a role of mirror. Number 1, play a role of mirror. So 9, when it see itself in the mirror, it see 9 itself. So 9 by 1 equals 9. 14 plus what? 14 plus what equals 15? Here, 14, what number we can add to 14 to get the number that comes after 14, which is 15? Do you remember? When add 1 to any number, you will get the number that comes after that number. So the result here must be 1 to get 14 plus 1 equals 15. Here in this example, 3 by 8 equals 3 by 6 plus 3 by what? In this example, we break apart a big number, which is 8, into two smaller numbers to make it easy to solve. So here we break apart number 8 to 6 and yes, when we break apart number 8, we break it apart to 6 plus 2. So the result here is 2. The last example here, what number we can multiply by 12 to get the 0? Do you remember when you multiply 0 by any number, the product always 0. So the missing number here is 0. Put the suitable sign plus or by for each of the following. Here in the first example, 1 and 12, and we get the result is 12. What is the suitable sign? We can put it here, plus or by. If we put plus, 1 plus 12, we get 13. But here, the result is 12. So what sign we can put here to get 12? Yes, we remember that any number, when we multiply by 1, we get the number itself. So here we get 12 itself. So the suitable sign here must be by. So 1 by 12 equals 12 because any number multiplied by 1 get the same number. The second one, 1, we have here 1 and we must put a suitable sign here, plus or by 6 to get 7. If we put by here 1 by 6, we must have 6, but here we have 7. So what is the suitable sign we can put here? 1 plus 6. Yes, 1 plus 6 equals 7, because if you add 1 to any number, you will get the number that comes after. And here we have 6, and the result is the number that comes after 6. So the suitable sign here is plus. Here we have 88, and I want to put here plus or by 0 to get 0. What is the suitable sign should we put here? If we put plus 88 plus 0, we must get 88, but here we get the result 0. Do you remember when you multiply 0 by any number, the product always gets 0. So the suitable sign here is by. To get 88, 88 by 0 equals 0. 26 and 1, we get 26. Okay, we remember that any number, when we multiply by 1, gives the same number. So the suitable sign here must be by. To get 26 by 1 equals 26 itself. Here we have 3 and 6 equals 18. What is the suitable sign? We can put here plus or by. If we put 3 plus 6, we must have 9. No, it doesn't work. So here we must put 3 by 6 to get 18. So the suitable sign here is by. 0 and 125 equals 0. What is the suitable sign here? When we get the product 0 here, so the suitable sign that we must put here is multiplication. To get 0 by 125 equals 0, because when you multiply 0 by any number, the product always 0. So the suitable sign here is by. 4 and 5, we get the result 9. If we put 4 by 5, we must get 20, but here we have 9. So the suitable sign here is 4 plus 5 to get 9. Check the following problems. If addition or multiplication, then find the result. Here we have a word problems. Says that Nada bought 2 dresses in a month. In the next month, she bought 3 dresses. So in the first month, Nada bought 2 dresses, and in the second month, she bought 3 more dresses. How many dresses did she buy in 2 months? In 2 months, we have to add the number of dresses that Nada bought. In the first month, she bought 2, and in the second month, she bought 3. So we will add 2 plus 3 to get the total number of dresses that Nada bought. So 2 plus 3 equals 5 dresses. The second one, check the following problem. If add or multiply, then find the result. Salma has 8 sets of crayons. Each set has 6 crayons. How many crayons does Salma have in all? Salma has 8 sets of crayons. Here we have 8 sets of crayons. Each set has 6 crayons. So, how many crayons does Salma have in all? In this problem, we will use multiplication because we have here by 6 equals 48 crayons. Okay, my dear students, that is all what we have in our lesson today. Okay, And at the end, I wish all best wishes for you. Goodbye.